My name is Akouvi. I'm the partnership and growth and partnership manager for UK and France at BizTech Europe. I've been working with built environment companies, avionics, for the last pretty much 15 to 20 years in their digital transformation journey with integration of 3D development software, being either a game engine or other software to allow them to get the best of this world. And today I'll be sharing how at BizTech we take static twins to live automated operations in any browser. And we'll be specifically looking at AR agents for digital twins in the metaverse. So today, cities and organizations need to build a digital first infrastructure. So it's virtual first and then physical. And this approach has been exemplified by NVIDIA CEOs, Jensen Huang, of his version of the metaverse, which is transforming industries at the moment. So factories are using the metaverse, or at least a version of digital twins within the metaverse. And this allows for planning, optimization, and also risk-free experimentation in a digital twin of a physical space, such as a factory, as I said. And this happens before any physical changes are made. Obviously, this has many benefits, and I'm going to talk about 3 of them. First is the risk reduction. By experimenting in the virtual world, that minimizes the risk associated with testing new processes and also new programs in the physical environment. The second benefit is efficiency that allows for faster iteration and optimization of processes before they are deployed, then saving time and resources. Sorry, somebody's going to join. I'll let them in. The third main benefit we can talk about is having the ability to have take informed decisions by providing detailed insights and data from simulations, then enabling better informed decision making. In theory, that sounds fantastic, but in practice, there's issues. And the main issue is that the current digital infrastructure platforms are limited. They are siloed, they are complex. They're complex to develop and also to understand. And there's lots of data coming in. How do you read the data? What do you do with it? And real-time integration is fragmented or inefficient. So at this BizTech, we come with a solution, which is turning digital twins into fully interactive multi-user environments, which are accessible in the browser. So we provide this browser-based metaverse platform that brings smart spaces to life. We add an agentic AI layer, so the operations move from dashboards to autonomous, auditable actions. We fuse real-time IoT data to improve safety, efficiency as well, and the experience in general across factories, ports, campuses, because we also work with education institutions and districts, if you talk about cities. The power of our platform is that it's built on automation. We have our AI agentic agent, HAL 8122, that listens to live data. It can test and execute approved actions. The platform then is flexible, that opens the door to multiple use cases and ideas, and you can iterate on the ideas and test over scenarios. It's simple as well, because you can use it from any devices. We allow to unify and breaking down any silos by adding any collaborators within the project. So you can have from the beginning of the project to the end, and you can add as many collaborators as you want. And which is also very powerful is the fact that our platform is persistent. It's always working and autonomous through agentic AI. So why are we doing that? Why now? Well, as we saw from last conversations and presentations, there's a global shift towards simulation-first decision-making. Organizations want to test potential solutions to problems before acting, which is wise. The Internet of Things, IoT, is becoming the Internet of Action through AI agents, but they need orchestration. And this is why HAL 8122 provides this. So now let's define AI agents and the metaverse as we see it. So agentic AI agents are real-time, intelligent, continuous, autonomous digital entities. Agentic AI agents in the metaverse manage tasks, they proactively make decisions, they predict outcomes, they interact with the environment and its users. They can handle tasks like monitoring environment, simulating scenarios, managing resources. They can also provide personalized assistance. That could be the case in healthcare, for example. They can also coordinate and manage systems, IoT devices, and automate processes. These intelligent agents are not just reactive, but they drive outcomes based on live data, on the goals set, and the contextual rules that are set up as well. So, for example, if you talk about urban agents, they manage utilities, traffic, and emergency responses. For industrial agents, we can see them, we can have them overseeing production metrics, machine health. They can also supervise safety protocols. For educational agents, they personalize learning paths and auto-generate lesson plans. So these agents, they work collaboratively to create a seamless and intelligent environment within the metaverse. And obviously, they're capable of turning data into actionables, into decision. Now let's see what's the metaverse as we see it at BizTech. The metaverse is an immersive, collaborative environment. And the collaborative part is really what makes it so powerful. Digital twins are at the backbones of this metaverse. We use AI for adaptability. You can have urban or societal scale metaverse, or industrial or educational. But what they bring is resilience, inclusivity, foresight, and large-scale collaboration. If you mix the agentic AI agent and the metaverse, you then create value for citizens and cities and factories, industries. So I'm going to show you a video and hopefully that will work. Let me see. Can you still see my screen here?
Yes, we can, yeah.
What about this one?
We can see it, but we cannot hear any sound. Do you have sound?
Yes, I thought I clicked share sound. It's okay. I can, let me try again. Can you hear any sound?
No, not yet.
Okay, sorry.
I think you might need to share your entire screen, maybe, or the application, and then go to advanced and say share sound.
Share sound. Okay, and now?
Yes, yeah. So maybe you can play from the beginning.
Okay, sure.
Welcome to the Curiosity Lab's Next Frontier, a fully photorealistic digital twin of the entire facility. Accessible from any device, anywhere in the world, this immersive environment connects people to real spaces in real time. Step inside as your own avatar and experience every corner of the facility firsthand. Interact with your surroundings and see operations exactly as they are, or as they could be. Shift perspectives instantly, from detailed first-person exploration to an intuitive isometric view. You can navigate the full floor plan, monitor activity, and maintain a bird's-eye view of ongoing operations. From IoT sensors to environmental control-less devices, and simulate outcomes before taking action. Visualize critical data at a glance. Here, a live temperature heat map is seamlessly overlaid on the 3D model, integrating sensor data from across the facility into a single actionable display. Meet HAL 8122, your agentic AI administrator. HAL can answer questions, run simulations, analyze patterns, and directly control connected systems, making every aspect of the facility smarter and more responsive.
We are BizTech, and we'd love to hear from you.
Yeah. So this video that you just seen, it's a video of a recent project that we've been working on with the city of Peachtree Corners in Georgia. And this is a digital twin of the Curiosity Lab facility. The Curiosity Lab is a test bed for it's a test bed for new technologies like 5G, AV infrastructure, and autonomous vehicles. And at the heart of this transformation, I'm going to try to see to the next. Yeah, at the heart of the transformation is us, BizTech, where we've been working with them. We created digital twins of 3 different places of the city. There's the city hall, the greens, and the downtown. And we are dynamically taking data from live feed cameras that have been placed in different places of the city. So in this part of this demo, part of the presentation, I'm gonna talk to you more about this project and how we are using AI agents to understand what's happening within the city and how we can replicate this as a blueprint for any other city environment. So what are we taking here? How are we applying AI agents? So for traffic management, we work with few partners like Atlas, and we allow the city to visualize dynamically on real-time congestion points, traffic flow, and potential hazards. Then that enable them to take proactive adjustment to traffic light timing and route optimizations in real time. So if they can see if there's any accident coming, if there's any congestion, the AI can inform the city officials and they can redirect the traffic. In terms of energy resilience, which is another point where Curiosity Lab was really interesting in seeing how we can add value with the AI agent. We integrate utility assets data from Circuit Meter, which is another partner, that allows for visualization and analysis of energy consumption and also the health of the infrastructure. That allows to predict maintenance and also balance demand in terms of electricity. For urban planning, the goal was to test and rehearse expansion plans of infrastructure and autonomous vehicle corridor within the twin first. Depending on the result, they could apply that in the real life environment. For incident response, the goal was to rehearse emergency protocols to simulate any hazards and then adapt dynamically. The goal was to have an always-on learning AI that will bring generative and agentic AI to simulate, but also to autonomously adapt to scenarios. The goal was to give data-driven information to always adjust and learn from the data to make decisions. Some of the goals and outcomes that we can take away, these are early outcomes, but we can already see some improvement. In terms of smarter mobility, so the adaptive signal timing managed to reduce congestion in peak hours. For energy resilience, the agents balance electronic vehicle charging demand to avoid grid stress. For preparedness, the simulations conducted revealed that there were some vulnerabilities to extreme weather then informing contingent plans. Obviously, they're in Georgia, so it's pretty much warm most of the time there. In terms of public safety, the predictive analytics flagged some hazards and bottlenecks before they escalated. And the main thing is collaboration practice. The immersive environment fostered dialogue between city and industry stakeholders. And all this was allowed by data-driven decisions from the IoT sensors. There was also an aspect from this project that was very important for the city officials to take into consideration, which was a human-centered dimension. We managed to bring trust and transparency by having explainable AI to gain stakeholder confidence. The collaborative aspect between the city officials, the industry, the researchers, and the community voices was the pinpoint of the project. Humans in the loop, the AI supports, but people always remain the decision makers, always. So in the Curiosity Lab project, these human-centered principles guide how AI agents and digital twins are deployed, ensuring that transparent insight from city officials are there. That way that foster collaboration across stakeholders, keeping humans in control of final decisions. As Brian Johnson, as you can see on the picture here, said, he's the city manager of Peachy Corners. By overlaying live data stream onto photorealistic digital twins, they can test development ideas, mobility changes, and incident response protocols in minutes. Even though the project is still a bit early on, we decided to keep track on some KPIs. And these KPIs are a combination of technical efficiency and platform performance. So we focus on performance and reliability of HAL, our AI agent, and the data ingestion. For the operational impact and planning efficiency, we take HAL and the digital twin as a whole, and we analyze on how it directly improves city management and planning processes. For the strategic value and scalability, we are focusing on the broader goals of the Curiosity Lab as a testing ground and the value of the collaboration. So you can see that some of the metrics that we are analyzing are some of the KPIs are the data ingestion fidelity, and then we will using a metric as percentage of real-world IoT data that are successfully integrated, and the error rate in the data translation. Of the rationale will be what's the platform ability to accurately and completely map physical world. For real-time latency, we will use the average time to run a complex simulation and how we can generate actionable recommendation. Rationale will be how we measure the live quality of a digital twin. Another example will be the user adoption rate, the number of unique city department users that are using Town Hall, so the AI agent, and the digital twin platform. And then we will measure the internal value and the integration into daily city operations. To summarize, the key learnings and takeaways that we can bring to this project with the Curiosity Lab at Peachtree Corners is trust in AI. These times are obviously trouble with AI trust and security issues. But if we provide an explainable and transparent decision-making process, which are essential to gain acceptance, not only from the city officials, but also from the public, we can trust AI. We found that visual explanations within the metaverse helped non-technical stakeholders understand agent behavior. And the agents come with, the platform come with non-playable characters that can also take them through, can onboard them, so that can reassure them in the whole process. Interoperability. The systems and data must connect seamlessly across mobility, energy, and safety domains. In practice, this means that our partners like S3 or circuit metadata and the IoT feeds into one current twin. There's no silos. It's easier to read. In terms of scalability, by deploying agents in one district first, provided a pathway to expand citywide and test what worked and didn't work. And we carefully planned data pipelines and governance accordingly. As always, human in the loop. So AI supports, but people decide. The city managers validated an AI-driven recommendations before implementation. This strengthened the trust in the system. And the AI agent transform digital twins from static replicas into adaptive, predictive systems capable of running continuous simulations and interventions. The metaverse provides a shared environment where you can have stakeholders, they can see, they can test, and can discuss the impact of AI-driven insights in real time. And also the public is part of this metaverse. They also have access to this environment. It's open. So what we want to show here is that the Curiosity Lab demonstrates, sorry, somebody wants to come in. What we want to show is that Curiosity Lab shows a scalable model for smart cities. And we want to show that it can be a blueprint to scale this approach, linking mobility, energy, and safety into one living ecosystem that other cities can replicate. We believe that AI agents for digital twins in the metaverse are not just optimizing systems, they are shaping the future of participatory, resilient, and sustainable cities. And one of the future outlook we can take is, as generative and agentic AI evolve, digital twins will become increasingly more autonomous, but governance and human foresight will remain critical. So there. And voila, that's for me. Thank you so much. I'm Akouvi Ahoomey from BizTech Europe. You can contact me on this email. I would love to carry on with the discussion with you guys. Thank you, Abel.